Hello everyone, we are from Princess Jurapan Science High School, Pathum Thani, Thailand. So today we are going to present you to our project, which is a novel of fuel briquette from periodic carbon back removal from West Thai pyrolysis to be as a source of energy in power plants to replace the use of coal. The organizer of this project is Thitipat Kongthong and me, Narupat Yachai, and our advisor is Khun Thong Thai Thong and Natasha Petin. Industrial plant or power plant use coal as primary fuel source due to the ability to generate electricity continually for 20 hours. The fact that coal is one of the cheapest fuel on the market result in the use of coal as an energy source increasing year after year. However, coal contribute significantly to carbon emission. Nearly 72% of carbon emission generated by power plants come from coal power plants alone. Additionally, coal contribute to micropollution and has sparked widespread concern, which is main factor of climate change and global warming. If we don't fix all these problems and keep this change in 20th century, the average temperature of world will increase by 5 degrees Celsius, which will cause big problem in the future. The other solve this problem as a threat to the future, which will lead us to search for substance. It is necessary to develop a material with similar property to coal with criteria of this substance has to have a high heating value, flammable, costly operation, and not expensive. After many hours of research, we found that waste from tripyrolysis, which is carbon black, has passed all the criteria and periodic is heating of a material in the absence of oxygen. Because no oxygen is present, the material does not combust, but the chemical compound that make up that material thermally decompose into gas, liquid, and solid. Usually, solid product of tripyrolysis end up in landfill. So the organizer therefore come up with the idea to develop to make an energy source from leftover recycling carbon back that can replace coal to replace the use of coal as a part to be as an alternative product to replace the use of coal. The coal used in the power plant are reduced pollution to make the environment, including reducing the cost of generating electricity. So we decide to test and create experiments about this idea. We start with mixed periodic carbon back from West Thai pyrolysis process of Pyro Energy Company, Saraburi, Thailand, to charcoal in property of 50 to 50, 25 to 25, 19 to 10, and 100 to 0 by weight. Then 6% biomass of gasoil was added. The P+ substance is then pressed in the beaker and stirred continually for 20 minutes. When the stirring is complete, add 40 ml of water gradually and transfer the resulting substance to the machine. Following that, we look for the briquette with the highest concentration of carbon black that can be successfully bond. It is a feature of our process. After we did the first study, we found that all the formula can be by expect 100 to 0 ratio cannot be more because the carbon back is hydrophobic, which makes it difficult to form the molecules to a low amount of binding of substance. After the observation, the most amount of carbon back that can be binded successfully is 90 to 10. And then we're curious that how much that will be the most sustainable tool for binding. So we prepare periodic carbon back to charcoal ratio from previous study. Then 2, 4, 6, 8, and 10% cassava step of the carbon back waste was being mixed. Then use the forming method like previous study. After that, we look for the briquette with the least amount of cassava step that can be bought successfully. After we did the second study, we found all the formula can be bond expect at 2% cassava step cannot be banned due to the low content of cassava step due to the absence of coagulation agents. After the observation, we found that carbon back briquette with the least amount of cassava can be bought successfully is 4%.
After we did the research on how carbon black can be bound into a high quality briquette, we curious what the property gonna be like. So we take the physical property and chemistry property of it. So we start off with the strength of the briquette by dot tests using ISTA 1A and ISTA 2A standard and using the formula as you can see in the slide. The briquette were dropped using robotic arm, using Arduino board and a computer to control the launch angle and the initial velocity. Then weigh all the briquette before and after the experiment was analyzed, as you can see in this picture. And this is the result of experiment. We can see that at the same briquette with the higher height, the mass after drop will be less since it cause more momentum and much higher impulse, which cause briquette to break. But at the same height, the more strength briquette binding phylolytic carbon black with charcoal are 90 to 10 at the same height. The more strength briquette binding phylolytic carbon black with charcoal are 90 to 10, 75 to 25, 50 to 50 in order. Because the amount of charcoal is the main contributor to the strength, the more of charcoal content will make briquette more strength. In summary, all the briquette are past standard of ISTA 1A and 2A. After test the strength, the most important things about briquette is this chemistry property. So we decided to create the study this property by sending the briquette to Thailand Institute of Scientific and Technological Research to ASTM D7582 and ASTM D5865 standards. After testing it, we found that this briquette has efficiency. Other than that, we found that chemistry property of carbon black briquette that the heating value is 33 megajoule per kilogram, which is higher than normal coal 75 to 40%. Burn high content is 7.5%. Fixed carbon content is 91.2%. Ash content is 0.8%, and moisture content is 2.5%. The results satisfy the orders since it have high heating value and cause less pollution than normal coal. But one thing that isn't normal is volatile content because it is too low. But in the real situation, by steam turbine and boiler, this will not be affected by this property. After all the scientific study, we found that this innovation have good potential to be alternative energy for future. So we decided to create the last study of it, which is business model and commercial potential of carbon black briquette. This found large number of consumers due to this high amount of energy output and low toxic emission. Commercial variety high, and after market validating, they have found a large number of consumer and variety type of coal have been imported to Thailand. Other than that, this is multi-million-dollar market size in Thailand is estimated at $1.6 billion. After doing a SWOT analysis, the board found that the events have a wide range of strengths and outstanding points that make it possible for business. After finding a business possibility, therefore create a business model of this work, which is said to have group of consumer is coal-fired power plant and many more, which consider the cost structure of this work. The cost per ton is $66, which is much lower than the cost of coal that we use today. And this is a picture of our business model using business model canvas and cost structure of this innovation. To summarize this innovation is good for environment because of this create less pollution that we use today and have very cheap price compared to normal coal. Other than that, we find that this innovation have a real consumer and business model, making it high commercial potential. And the primary result of this study led to our future work, which is to burn carbon black bracket to determine the impact on air pollution and the environment as a whole. Thank you for your attention to our presentation. Goodbye. And we hope that this innovation will lead to the world to be a better place than before.